Two ropes are pulling upward on a large crate with a weight of 306 newtons. The tension in the left rope is the same as the tension in the right rope. If the crate is moving upward at a constant speed, what is the tension in the left rope? So first, let's draw a free body diagram for this problem. So this is the crate, and it's 306 newtons. So the force due to gravity, which is the force downward, force due to gravity, its weight is 306 newtons, and the tension moves upward, and there's two ropes, so left rope and the right rope. So the tension in the left rope is TL, and then the tension in the right rope is TR. And we know that TL is equal to TR because it says here the tension in the left rope is the same as the tension in the right rope. So let's use our generic formula for force problems, Newton's second law, which is the net force is equal to the mass times the acceleration. And we know that the acceleration is equal to 0 because the speed is constant. So velocity is constant, that means that acceleration is 0. And we can find the mass of this crate by dividing its weight by 9.8. So 306 divided by 9.8 gives us 31.22 as kilograms as this crate's mass. So F net equals 31.22 times 0. So F net is equal to 0. And that tells us that all of these forces acting on it combined must equal 0. So the tension in the right rope plus the tension in the left rope plus the force due to gravity must equal 0. So tension in the right and tension in the left rope are both the same, so we can just write 2T, T plus T, 2T, and then the force due to gravity is 306 newtons downward, so we have to write minus 306 equals 0. So if we add 306 to the other side, 2T is equal to 306, and then we can divide both sides by 2 to get the tension in either rope to equal 153 newtons. The second part of this question asks, if the crate is accelerating upward at a rate of 1.89 meters per second squared and the tension in the two ropes is the same, what is the tension in the left rope? So we can apply the same formula, F net is equal to MA, and this time acceleration is not 0, it's actually a number. So this is equal to the mass, which we figured out before to be 31.22, and the acceleration is 1.89 meters per second squared. So we know that since it's positive, it's upward. So we can multiply these two and get 59.01. And we know from the previous problem that F net is equal to all of the forces acting on the crate, so that is 2T minus 306 is equal to 59.01. So let's add 306 over to the other side to get 2T equals 365.01, and we can divide both sides of the equation by 2 to get the tension in either rope equaling 182.50 newtons.